আজকের আমাদের টপিক প্রজেক্টাইল মোশন অন ইনক্লাইন্ড প্লেন। প্রজেক্টাইল মোশন অন ইনক্লাইন্ড প্লেন। নর্মালি আমরা যেটা জানি, প্রজেক্টাইল মিন্স কম্বিনেশন অফ ভার্টিক্যাল অ্যান্ড হরাইজন্টাল মোশন। একটা বডিকে সামথিং একটা অ্যাঙ্গেলে যদি আমরা প্রজেক্ট করি, দেন বডিটা ভার্টিক্যাল মোশনও কভার করছে, আবার সঙ্গে হরাইজন্টাল মোশনও কভার করছে। দ্যাট ইজ নোন অ্যাজ প্রজেক্টাইল মোশন। এখানে আমরা যে টাইপ অফ প্রজেক্টাইল মোশন রিপ্রেজেন্ট করব সেটা হলো প্রজেক্টাইল মোশন ইন ইনক্লাইন্ড প্লেন। তো কনসিডার দিস ইজ অ্যান ইনক্লাইন্ড প্লেন consider angle of inclination here that equals to theta. Angle of inclination equals to theta. And consider a body is projected from point O with a velocity of v0 at an angle of alpha. At an angle of alpha. So along the vertical, the component of v0 is v0 sine alpha. Along the horizontal, the component of v0 is v0 cos alpha. এবার বডিটা একটা ম্যাক্সিমাম হাইটে রিচ করবে। At the maximum height, y component of final velocity becomes 0, but the x component remains the same, that is v0 cos alpha. আর বডিটা আলটিমেটলি গিয়ে রিচ করছে পি পয়েন্টে। Now this OP, that equals to R. R means range covered by the projectile or the maximum horizontal distance covered by the projectile, that is known as range. Now here the acceleration due to gravity is also acting at an angle of theta. Therefore along this the component is g cos theta, and along the inclined plane the component is g sin theta. So for the motion along x-axis in the interval O to P, here ux, that equals to v0 cos alpha, ax, that equals to g sin theta, and time of flight, that equals to 2v0 sin alpha by g cos theta. This is time of flight. Now applying the kinematic equation along x-axis, x equals to ux into t plus half into ax into t square. Now put the value of t here. R equals to v0 cos alpha into 2v0 sin alpha by g cos theta plus half into g sin theta into 2v0 sin alpha by g cos theta, that whole square. By calculating this, we get the value of r as 2v0 square sin alpha into cos of theta minus alpha by g cos square theta. This is the value of range for the projectile is in inclined plane. Now, condition for the maximum range. We get the value of range as 2v0 square sin alpha into cos of theta minus alpha by g cos square theta. For the maximum range, dr d alpha, that must be equals to 0. So if we differentiate this equation with respect to alpha, then ultimately it become d alpha of sin alpha into cos of theta minus alpha, that equals to 0. That means sin of theta minus alpha into sin alpha plus cos of theta minus alpha into cos alpha, that equals to 0. That means cos of theta minus 2 alpha, that equals to 0. That means theta minus 2 alpha, that equals to pi by 2. So alpha equals to theta by 2 minus pi by 4. For the maximum range, alpha equals to theta by 2 minus pi by 4. Hence, the range of the projectile is maximum when it is projected at an angle of this. Now we have to find out the maximum value of range. And the maximum value of range R max, that equals to 2v0 square into sine of theta by 2 minus pi by 4 into cos of theta plus pi by 4 minus theta by 2 by g cos square theta. Now, by simplifying this equation, we get the maximum value of range as v0 square by g into 1 minus sine theta. This is the maximum value of range when the projectile is in inclined plane. Now consider an example. A projectile is thrown at an angle of alpha with an inclined plane of inclination beta as shown in the figure. Find the relationship between alpha and beta if the projectile strikes the inclined plane perpendicularly. So here G is acting at an angle of beta. Along this the component is G cos beta. Along this the component is G sin beta. Here the component is V0 sin alpha, and here the component is V0 cos alpha. So Ux equals to V0 cos alpha and Ax equals to minus G sin beta. At the striking point here, at the striking point, suppose at point P, Vx becomes 0 at P. Now applying the kinematics equation along x-axis, we get Vx equals to Ux plus Ax into t. Here Vx is 0, Ux means V0 cos alpha, Ax means minus G sin beta, and value of t is 2V0 sin alpha by G cos beta. Now solving this, we get 2 tan alpha, that equals to cot beta. This is the relationship between alpha and beta if the projectile strikes the inclined plane perpendicularly. Now next problem is, a stone must be projected horizontally from a point P which is h meter above the foot of a plane inclined at an angle of theta. With the horizontal as shown in the figure, calculate the velocity v0 of the stone so that it may hit the inclined plane perpendicularly. Now here G is acting at an angle of theta. Therefore, along this the component is G cos theta. Along the inclined plane the component is G sin theta. This angle is also theta, that means along this the component is V0 cos theta, and along this the component is V0 sin theta. Here is the motion of the projectile. This is the motion of the projectile. Let the projectile hit the inclined plane at point Q. Now in the interval from P to Q, Ux equals to V0 cos theta and Ax equals to minus G sin theta. At the striking point Q, it strikes perpendicularly. That means Vx equals to 0. So Vx equals to Ux plus Ax into t. Now by putting the value of Ux and Ax, we get the t equals to V0 cos theta by G sin theta. We get the value of t as. Now the motion perpendicular to the plane, that means along the y-axis, Uy equals to V0 sin theta, Ay equals to minus G cos theta, and Sy, that equals to minus H cos theta. So apply this Sy equals to Uy into T plus half into Ay into T square. Here the value of Sy is minus H cos theta, that equals to minus V0 sine theta. Sorry, here Uy equals to minus V0 sine theta into T plus G in half into minus G cos theta into T square. Now put the value of T as V0 cos theta by G sine theta in this equation. Then we get value of H as H equals to V0 square by G into 1 plus cos square theta by 2 sine square theta by putting the value of T. That means H equals to V0 square by G into 1 plus cot square theta by 2. That means 2GH, that equals to V0 square into 2 plus cot square theta. So V0 square, that equals to 2GH by 2 plus cot square theta. That means V0 equals to root over 2GH by 2 plus cot square theta. This is the value of V0 if the stone hit the inclined plane perpendicularly.